Hi everyone. In the last lecture we discussed about routing information protocol with its components and the functions. And in today's lecture we are going to discuss about Internet Protocol version 4. We obviously call this as IPv4. In the agenda of the today's lecture we just give a brief note on IPv4 and then we discuss about the IP datagram. And then we also discuss about the IP fragmentation and reassembling of the fragmentations. And then we discuss about the IP services and its components. And at last we discuss a brief introduction to the IP components with its functionality. IPv4 Internet Protocol version 4 works at the network layer of the OSI model and also at the internet layer of the TCP IP route suite. And this protocol is called as the core protocols, that is based on the internetworking methods, and this is being used to route the packets from source to the destination nodes. This is also being used in the packet switching networks also. And this protocol is the first protocol that is being deployed for the SANnet in the year 1982 and also for the ARPANET in the year 1983. IPv4 has the responsibility to route the packets from source to the destination nodes in the network. And all the hosts are given the logical addresses, which is otherwise called to be as the IP addresses, whereby they can easily identify to route the packets. IP network has the responsibility of identifying all the hosts by using a different addressing scheme. This addressing scheme is called as the best effort delivery packeting scheme or the best effort addressing scheme, wherein the packet delivery is not guaranteed, that the source initiates the packet and the destination may or may not receive the data packet. And now we'll look into the concepts of the IP datagram. The packets on the network is called as the datagram, and this datagram comes out with a variable length packet with two different parts in it. The first part is called as the header, which has the 20 bytes in length. The second part is called as the data, which comes out with the 60 bytes in length. This addressing scheme is called as the best effort delivery packet addressing scheme, wherein the packets delivered will not be a guaranteed one, where the source initiates the packets and the destination node is not guaranteed to receive the destination packet. And now we look into the general format of the datagram, wherein the first part is called as the version, that is nothing but the IPv4. The second part is the header length, which has got 32-bit word in length. The third part we call this to be as the type of service, which is nothing but the priority service, and this is not used by the IPv4. The fourth part is the datagram, wherein the datagram length comes out in two parts. That is, the first part is the length of the header plus the second part is the length of the data in bytes. Now the next part we call this to be as the TTL, which is nothing but the time to live. So this ensures to implement to trace the route of the packets, and the packets are eventually dropped when the packet ensures the concept of looping. Now the next part is called to be as the protocol ID, and this ID is meant to identify the type of the protocol, either your protocol is the TCP or it is an UDP1. The next part is called as the checksum. This is the error reduction method that is used to identify the number of bits sent by the source node is the same received at the destination node or not. The checksum is calculated by the sender node and it is sent along with the data packet. And now what happens is that upon receiving these data packets at the destination node, the destination node also calculates the same checksum and reproduces the same number of bytes received by the sender nodes. And now the next integral part is that about is the source IP address followed by the next part is the destination IP address, and the next part is the option. This option part is not used by the IPv4, and this is used by the networking for testing and debugging purposes. And the last integral part is called as the data. This is the actual data that is need to be sent from the source to the destination nodes. Followed by the checksum is the source IP address and the destination IP address, and followed by the destination IP address is the option. This option integral part is not used by the IPv4, and this is used by the networking for testing and debugging purpose, and the last part is called as the data. Now the solution to this problem is that the datagram is divided into small chunks, and these small chunks are called as the fragments. And where the fragmentation is done and what is involved in the fragmentation. And now we look into the concepts of fragmentation. Why do we go for fragmentation and what is the need for the fragmentation is all about that. Every network is said to have its own MTU. MTU is the maximum transmission unit, and this maximum transmission unit is defined as the maximum size of the datagram, and this is imposed by the data link layer in the network. Upon reaching the destination, the routers help us in reassembling all these fragments and framing into the datagram. Now we look into what is involved in the fragmentation. The general format of the fragmentation goes like this with the datagram packet formats. The first part is your version part, followed by the second one is the header length, followed by this the datagram length or the total length of the packet, and the word 2 takes out the identification with the 3 flag sets as the DF flag set and the MF flag set and the fragment offset. The word 3 goes like this with the TTL, which is the time to live, followed by the protocol ID and followed by the checksum. And now the identification of the word 3 for the fragmentation is to identify from which the host is getting initiated with the datagram, so that the datagrams are divided into small chunks called as fragments. The second field is called to be as a DF field. DF field is don't fragment field. It means that the datagram is not set to get fragmented provided that the MTU is very small to get fragmented. The next field is called as the MF field. The MF field is said to have more fragmented, means the datagram is said to get fragmented for several number of times in the network. The last one is the fragment offset, followed by the TTL, protocol ID and also the checksum. Now we look into an example for the fragmentation. Now consider that the first network is said to have an MTU of 4000 and another network is said to have an MTU of 200 and another network is said to have an MTU of 1500, etc. Now the whole of the datagram packet has to be converted into a small chunks. We call that to be as the fragments, and this is done either by the sender or by the intermediary router. Now consider an example that if a network has an MTU of 4000, here the datagram is divided into two parts, like the header goes with the 20 bytes long and the remaining of 3800 bytes is considered for the data, and the MF bit is set to 0 provided this is the first fragment of the datagram. Now we look into the concepts of IP addressing. The IP addressing comes into two important categories. The first category is called as the flat addressing scheme. In the flat addressing scheme, each router is set to recognize the host with a 48-bit MAC address. And now the router is set to identify all the hosts that is connected to the internet. And this is very hard to maintain, and this is also very slow to convergence. To overcome this remedy, we have another type of networking scheme, addressing scheme probably we call that to be, that is the hierarchy addressing scheme, where the address is divided into small segments and each and every segment is said to have the specification of the address to identify the host in the network. IPv4 uses a 32-bit addressing scheme, and this addresses are being separated by the dotted lines, and this is stored in a big Indian order format. And these addressing schemes need to be located or to be addressed by each and every router table that is getting used by the routers. The IP addresses are managed by the three important communications corporation, that is the IANA followed by ARIN and also by ICANN. All the addresses, that is all maintained universally by these three important corporations. Now we'll look into the concepts of IP services. The IP service is otherwise called to be as a datagram service. IP service comes under the three important categories. The first one is the unreliable, the second one is connectionless, and the third one we call that to be as a best effort one. When coming to unreliable, no attempt is made to recover the data packets that is getting lost during routing. And the second one is the connectionless, where each packet in the routing is said to be handled independently. And the third one is the best effort, where there is no guarantee that the packet that is sent by the sender will be received by the receiving node. In continuation with the IP services, there are four different types of routing that is being supported by the IPv4. The first one is one-to-one routing. We call this to be as an unicast. This is supported by Class A, Class B and Class C addressing schemes. And the second category is that one-to-all. This is called as broadcasting. This is supported by 255.255.255.255 addressing schemes. The third one is all about the one-to-many. This is an multicast addressing, where this is supported by Class D addressing scheme, and the last one is all about is the one-to-all, and this is called as the anycast routing, and here this is not supported by the IPv4. And now we'll look into the concepts of IP components. From the upper layer of the protocols, the whole of the datagram packets is divided into small chunks. We call that to be as fragments, and this is being done by the processing module, and this is forwarded to the forwarding module, wherein this is getting updated in the routing table, and in turn it's given as an input to the reassembling table. With the help of the reassembling table, the whole of the datagram packets and the fragments forms into the actual data, and the actual data is getting forwarded to the next higher level protocol. We have come to the end of the session. Hope everyone understood the concepts of IPv4. We learnt about the IP datagram, we learnt about the fragmentation, IP address, and also about the IP services and its components. In the next session, we are going to discuss about OSPF routing protocol and its fundamentals. Thank you.